First, I want to explain a few things. You were supposed to read course information. The course information is right here. I'm on the Blackboard course. Course information basically has yeah, right there. It has all the information about the course, and I wanted you to read that before um, before too long. You have time until February 8th to read it and take the quiz. There is a quiz you have supposed to take, which is you're checking your understanding of course information. So you need to read all this and then take the quiz one. The quiz one is found here in the tests and quizzes section, which is right here. You see the quiz one. You need to take that only after reading the course information. And then if you go to faculty information, there is my, sorry about that, I closed it. So let me open it again. Okay, my email address is there in the faculty information. It's profcoogan@gmail.com. This email address is dedicated to the students, so if you write to this address, I'll get to it faster. So if you have questions or concerns, anything you want to talk about, you can write to this email address. If you write to the John J email address, it'll be slower because there are all kinds of junk mails coming into that mailbox. So please use this one instead. Also, the course information tells you, course information is basically your syllabus. Everything you would normally see on the syllabus is here. So for example, few things I need to highlight. This section tells you how your achievement will be measured. And there will be 3 tests carrying 35%, final exam carries 30%, assignments and projects together carry 35%. Lowest passing grade is 55, but 55 to 58 will be a D minus. That's a poor grade. You don't want to get D minus. So it tells you what grade you have to get, what number grade you had to get for each letter grade. And the other thing is your attendance. There will be attendance taken at the beginning of class, and if you come after the attendance is taken, then you're late. And every lateness is same as 15 minutes of the class missed. And these latenesses should not add up to more than 5 hours. So latenesses and missed classes should not add up to more than 5 hours. If they do, then you fail the course. If you have perfect attendance, then you get rewards. Or even if you have moderate attendance record, you still get a reward. So let me explain that. If you have perfect attendance, which means you could have missed 15 minutes of the class, no more than that, then you get 2 rewards, which is the lowest test grade will be dropped and two lowest assignment grades will be dropped. Those are the rewards. If you have missed one class, but if you have missed only one class, no more than that, then you get the second reward, which is dropping 2 lowest assignment grades. And if you miss more than 5 hours of this course, then uh, you will be failing the course. There is a tutor assigned for this class. You know, this class, this is computer programming class. So it's a little bit more than math. You know, it requires some math skills. Hold on. Okay, it requires math skills, and it's basically like an applied math. You know, uh, no math directly. You know, I'm not going to give you math questions here, but the skills you develop by taking math classes is what you need. That skill will be necessary here. So if you're a student who says, you know, I love math, then you're going to love this subject, computer programming, and you will do very well. If you're a student who says, I hate math, then you're going to have trouble in this class. You're not going to be doing very well. You may have to rethink about this because this course requires mathematical skills. It's not really direct math knowledge. I'm not going to give you calculus problem here. There will be no need for calculus, but the skills you develop by taking a math class is kind of necessary. And some of you are born with it. Some of you gain it through math classes. Some of you just cannot handle it. And so those who cannot handle the math would have trouble here in this class. Well, you will know after a while whether you can handle this class or not. And when it becomes clear you cannot handle it, I will recommend dropping the class because then otherwise you'll be wasting time and effort that you could use in another class. So this since the course is difficult, you know, the college provides enough help. One of them is this tutor. There's a tutor assigned to this class, and he will be available for you to contact, communicate with you through email. So I have a link here called Contact Tutor that tells you the tutor's email address and also his regular meeting. He will be offering a regular help session every Thursday at 4 p.m. 4 to 5 basically, but you have to show up at 4 if you need help. If nobody shows up for the first 10 minutes, he will leave. So you have to show up at 4 if you need help. That's every Thursday. Now that's not all. You could write to him your questions, or you could ask him for a help session and he can set up a Zoom meeting for you and things like that. So feel free to contact him and get help. And I will be also having office hours 2 to 3 every Monday and Wednesday. That's only on Monday and Wednesday. So he's available on Thursday, not only on Thursday, he's available every day through email. And on Thursday, he's going to be available at 4 in a Zoom meeting. So that doesn't mean his service is limited to Thursday. All right, he's a tutor for this class. So anytime you need help, you can contact him. And you can also write to me when you have a question or concern to the address I gave you, the Gmail address. Also, the course material are right here. Before that, let me tell you about announcement. Anything I want to announce about even sometimes due date change or things like that, I post it here at the announcement, and everything I post here will also come to you as an email message. So every announcement will come to you as email message, and if you miss it for some reason, you want to you don't have the message, you can come and look up here in the announcements. Also, the course is divided into 6 modules, and after first 2 modules, there will be test 1. After another 2 modules, there will be test 2, and so on. There will be 3 tests. So each module tells you what course material will be used. For example, class 1 will be PowerPoint lecture 1, and class 2 will be PowerPoint lecture 2, and so on. I have posted the videos of these lectures from past, but later, after each class, I will be posting the actual video of this class, my presentation to you. I'll be posting that instead of these. But these are there if you want to review them before class. They're there. So the modules are right there, and course supplements give you some supplementary material. For example, the chapter 1 of your textbook is right here. I'm giving that chapter 1 for everybody. I have the permission from the publisher for providing the chapter 1, because some of you may not have the book at this point. You may be waiting for it. And there are some other students who are on financial aid, and they have to wait for the voucher to buy the book. And for those reasons, I have the chapter 1 available. Now, before we finish chapter 1, you should have your book ready. Error corrections in the book, there are errors, and I have made a document that shows the error corrections. As soon as you get your own copy of the book, you should make these corrections by hand on your copy, so that you don't have to work with the errors anymore. Sometimes it's a question that is wrong, a project that has a mistake. So you don't want to work with the project that has the wrong statement. So therefore, make these corrections. That way your projects and homework will be correct. There are other things. As the course proceeds, I will let you know what is what and why you need these supplements. And the tests and quizzes section will have the tests and quizzes. Now, there is a quiz right now, and I already send you this announcement that tells you that you have to read entire course information and then take this quiz. This quiz will check your understanding of the course information. Course information is the syllabus. I didn't want to call it syllabus, but it is same as syllabus, and you need to understand everything in there, and that's why this quiz will check your understanding. So it will count as a graded assignment. So please take it after reading the course information and try to get the best grade you can get. Course calendar tells you exactly what will be taught in each class. So here's class 1, we'll be doing section 1.1. And after that, what is due? What is the homework? That's right here. Section 1.1, all the questions will be your homework. There will be a homework after each class. And you should write up your solution and turn it in. So today, after today, before this exercise 1.1 will be due 5 minutes before the next class, the beginning of next class. Next class beginning will be 9:25, so this will be due at 9:20. And if you miss that deadline, you won't be able to turn it in. So please write up the solutions and submit it. How do you submit the assignment? I'm going to show you how. You go to the assignments link, and there you'll find this link right there. CSCI 271 Homework 1, Section 1.1. If you click at that link right there, it'll take you to the area where you can fill out your name information. Where did it go here? Okay. So it asks you to uh, put your information here, your first name, last name. Submission title means what assignment it is you're submitting. You can just call it assignment 1 or section 1.1, something to identify that homework. And then choose the file from, by clicking here, you'll choose the file from your computer. The file has to be already somewhere on the computer or some other media. If by clicking here, you'll be able to find it. And then after you find it, you'll be able to upload by clicking here. So this document, your solution should be already on the computer in some form. Technically, it'll take any form. It can be JPG picture or PDF file. Any file will be accepted, but if you handwrite and take a picture of it and then upload it, that'll work. But these handwritten or the JPG files and PDF is okay, but JPG especially doesn't seem to work very well from my past experience. My feedbacks are difficult to read if you submit a JPG file. So I strongly advise you to type your answers. It shouldn't take too much time. Do not type the question again. There's no need for it. You're wasting your time and you're wasting my time too. You know, I will be, when I grade, I will have to see it, you know, if you write that, you know, even if I don't spend the time reading it. So if you don't write the question, it'll be much easier for you and me. So just type the answers. Type up the answers and save it as in any format. Use any editor. It doesn't have to be a word processor. Even the Windows offer you various editors, including Notes. So use some editor. Word processor will be nice, and you don't have to have a word processor. If you don't have one, just type it using some other editor. So upload a typed document, then it'll work best for the grading and feedback, and everything will work best. But what you can only upload one document. So no matter how much material you have to make it all one document. It can be several pages long, but one document only. Even the projects have to be one document. So everything you need to put into the project have to be made into one document and you upload it. It won't allow you to upload more than one document. All right, cancel that. Feel free to ask your question any point at any time. Always, if you want to find out what your grades are, you can click at My Grades and it will tell you the details of your grades for the assignments, the tests, no matter what you have done at that point. You can see the grade right here. Discussion board is useful for various, for all of you to discuss with each other or discuss with me. You put up anything on the discussion board, somebody will respond. And I will also respond whenever I see it. Also, the course messages will be very similar to discussion board, but it'll be basically like sending messages to everybody. So if you use course messages, you're sending a message to everyone in the class. So it may be a question, or it may be some concern or something you want everybody to know. Feel free to use it for any purpose. Basically, it's a way of communicating with the entire class instead of just one person. If you send an email message to me, that only comes to me. But if you send it to this course message, it'll go to everybody. Blackboard Collaborate is useful to have a meeting with somebody It works just like the Zoom meeting. You can meet with other students through Blackboard Collaborate. Okay, so basically that's all I wanted to mention on this. But yeah, let me point out one more thing. The course calendar, I mentioned to you about the course calendar. This tells you what will be taught in each class and what is the what is due after that. And you can always check this what's due when. That is an actual calendar. Click at the calendar and it tells you what is due on each day. So for example, right now, it says on Wednesday, you have an assignment due right there. You can click at that, it'll tell you what that is. It's assignment 1, homework 1, section 1.1. It also tells you on Monday the 8th, you have 2 things due. One of them is introducing yourself on the discussion board. That's another assignment. On the discussion board, you're supposed to introduce yourself. And if you go there, you can see others have introduced themselves. There's already some students who have done that. You need to post your own introduction there. That's should be done before February 8th. And also you have the quiz. Quiz is also due February 8th. You have to do that by February 8th. So to take the quiz, you had to read the course information first. That's all right. That's all I need to mention. Michael Tehut. Someone just came in.
Sorry, Professor. I was already here. I just couldn't hear you, so I had to just restart.
Oh, you had to switch. Okay. All right. That's fine. Okay, so that's all I need to mention. Any question about the course website, Blackboard? All right. So I'm going to get out of that and start our first class material, Introduction to Computer Programming. That's our course. First, in this chapter, you're going to get an introduction to the basic structure of the computer and important components and, some of the details of the hardware. And you will also understand the computer program, and you will understand what a programming language is and what languages are out there and what is a machine language and what the compilers are for. All those details you will be learning in this chapter. So let's begin with the definition of a computer. A computer is a machine that's capable of accepting, storing, and acting on data and a series of instructions given to it by the user. It will achieve them at great speed and high degree of accuracy. So it's basically, one second. The computer, I may be asking questions like this. What is a computer? You have to write the definition with the keywords have to be there. Basically, the computer is a machine that is capable of storing and acting on data and instructions given by the user. That's basically the definition. It will achieve those in great speed and high degree of accuracy. So the speed and accuracy are important features of the computer that we take advantage of. So let's understand solving a problem using a computer. If I'm going to use the computer to solve a problem or achieve any task, then first I have to know how to solve that problem. And then I have to do more than that. More than knowing how to solve the problem. I have to be able to break up the method of solution into very simple steps that the computer can follow. Well, very simple steps that the computer can follow would be same as simple step that a person with no brain can follow. See, this is a machine we are writing instruction for. It doesn't have a brain. It cannot figure out anything. So your instructions have to be very clear and very basic, the simplest. It cannot expect anything from that machine. It has to, a machine should be able to follow that instruction without any other help. So that's the kind of instruction you had to write. So that's why this set of instruction you write is what we call program. So the program is basically a set of very basic instructions that the computer can follow to achieve the task. And so the programming is difficult because of that nature, because it is the kind of instruction that a machine can follow. So a machine cannot figure out anything, so it has to be, very basic instruction, and it has to be very accurate. No error can be there. If there is any error, the computer cannot figure out what it is or what you're saying in your instruction. So that's why it's not very easy. So let's understand the computer program. The set of instructions written for the computer to guide it through the process of achieving a specific task is called the program. This kind of question will be there in your homework, in your test, and things like that. What is a computer program? So then your answer will be, a computer program is a set of instructions written by the programmer to guide the computer through the process of achieving a specific task. That's what the definition is. You had to, if you write that, you can write it in your own words, but some key ideas must be there. So in this definition of computer program, the key word is instructions. Computer program is a set of instructions. If that word instruction is not there, then it's probably wrong definition. So you can use your own words, but some keywords need to be there. Okay, so software and hardware. The program, when it is a professional program, basically, a marketable program, then we call it software. But essentially, software and program are the same. The computer system is called the hardware. Writing a computer program is called the computer programming, and that's what you're here in this course to learn, the computer programming. Why write a program? So let me ask you the question a little more carefully. We know that writing a computer program is more difficult than solving the problem itself. So if you have let's say you have a quadratic equation to solve, you had to first know how to be able to write the program to solve it. You had to first know how to solve it. And not only that, you had to break up the system, the solution process into very tiny step-by-step, the basic level step-by-step instructions that the machine can follow. So breaking it up, breaking that process into these step-by-step instruction is not easy. It's often difficult. So solving the problem ourselves is easier than writing the computer program. So why do we then write computer program? Can anybody answer? You have to unmute yourself before answering the question. Can anybody tell me why we write computer program, even though computer program is harder to write than solving the problem itself?
Because sometimes the computer might not take in all the information that you asked them to solve, like from the problem.
Another, the problem, if I want to solve a problem like quadratic equation, I can solve it myself faster than writing a computer program. Understand the question?
Yeah.
So why bother to write the program? That's my question. I think you misunderstood my question.
So it's like, for example, if you were to write out the quadratic formula, you have to do it consistently every single time for every single problem that you have. Whereas if you program the computer to know what the quadratic formula is, you don't need, you only have to do it once, and then from there on, the computer will do it multiple times for you.
Exactly, that's the right answer. The computer program, you only write once, and then same program can be used to solve similar problems over and over, and not only for me, but also for the rest of the world, right? Everybody out there can use that program to solve quadratic equation that they have to solve over and over. So the whole world can use it over and over. So that's why we do that. Exactly. So think about the word processor. Somebody wrote the word processor. Now we are all enjoying it. We are all having easy time writing our term paper and everything using the word processor. And that's the benefit. Everybody can benefit once the program is written. That's why computer program is important. Once you write it, it's good forever, good for everybody out there. Computer programming is the only way we can use the computer. Then why do we like to use the computer? Why do we prefer a computer over a human human to solve a problem or do the work, even payroll or things like that, payroll or phone bill, all these are done by computers now. In the past, they were done by humans. So why do we prefer computers? Here are the reasons. One is accurate. It's always accurate, but humans make errors. When humans do this billing in the past, I didn't, I had some experience of these bills made by humans having errors. People had trouble all the time with the bills, when they were made by humans. There's always mistake, error. You had to call and argue with them and get that sorted out. It happened every time, every bill. But after the computers took over the bill, nobody has any complaint. Did you ever have a complaint about your phone bill? No. About your electric bill? Not at all. Not anymore, because they're all done by computers now. So they are always accurate. The other one is they are extremely fast. They're as fast as electricity. So no human can beat that speed. So what takes months for people to do can be done in seconds by the computer. All these billings and uh, all the calculations it needs to do the billing, everything is done in seconds. And the other aspects are uh, computers never get tired, don't ask for coffee or snack, right? Smoke break, none of that. So it works forever and without any break, without anything that from you, and that's amazing benefit right there. And also, it's once you write the program to do the certain job, it'll do that job over and over uh, forever. And it is a honest worker. So, clearly, so many things are there better than humans. And so there are all the reasons to prefer the computers. Only thing is you have to write the program. So whatever you're doing with the computer, you have to have a program written for it. And you have to do it only once. Okay, so let's understand the computer system. A computer system means a little more than a computer itself. That's because the computers need other devices to be able to work with them. So there are several components that have to go with the computer. There are three components, three important components are there. Input device. Input device is the device that allows a person to communicate the data to the computer. So to provide the data, even to provide the computer program, you need some device. Keyboard, diskette, mouse, scanner, these are examples. Diskette is not used anymore. CD is still in use. So those are all input devices. An output device would be a device that would allow the computer to communicate the results of executing a program, the final outcome. And this is usually, the output device is usually a monitor. The outcome shows up on the monitor. Printer is also considered to be output device. Central processing unit, or CPU, is the computer itself. That is the core of the computer. So these are the components of a computer system, actually. So let's look at the CPU, the central processing unit. Inside the central processing unit, there are two units called processor and main memory. The processor contains two units within it called arithmetic logic unit and control unit. The main memory is outside the processor, but it is connected to the processor. So main memory is something we need to understand a little bit further. It is not the same as the external storage, such as the CD, or where you store things, or hard disk. Those are called external storages. The memory is an internal unit. It's not same as storage. It is just like the memory in human brain. It is used only by the computer. Just like our brain uses our memory and brain, kind of work together. The computer works the same way. It needs a memory to be able to function, to be able to carry out all the tasks, and it will be using memory to achieve everything. So memory is more like a workspace for the computer. So we have no access. The humans, when we use the computer, we are not accessing the memory at all. It is the computer processor is the only one that accesses the memory. So we only have access to the external memory, where we store things, save our files and things like that. We cannot do anything with the memory. So what is the memory for? For the computer to do the work. For example, the program, any program that we execute has to be first copied into the computer memory. And only after it goes into memory, the computer can execute them. It's just like if I need to do something and you give me instruction, I have to have that instruction in my brain. First, I have to take that instruction into my memory before I can carry out those instructions and execute the task. So in the same way, the computer has to have those instructions. The program is a set of instructions, and it has to have those instructions in the memory before it can carry them out. Also, all the data that computer needs to process have to be in the memory first. So anything you need to have the computer work with, you had to move them into the memory first. And that's why the memory is there. It's just like our human brain. The computer is a device that kind of mimics the computer, mimics our brain. So when I need to do things, I have to know how to do things. That's the instructions of how to do them. They have to be in my brain, and the data that I'm working with have to be in my brain. Like if I'm adding two numbers in my head, I have to take those numbers into my brain first, into my memory first, and then add those numbers in my brain. So it's the same way. The computer can add two numbers only if it has those numbers in the memory first. So in fact, after you start programming, you will see all that. Your instructions are going to be telling the system to do something to the memory. Every instruction you write in your program is an instruction telling the computer to do something to the memory. So that's what the memory is for. It's for the computer to use to achieve its tasks, not for us to use. So this memory has to be enough. You know, there should be enough memory for the computer to work with. You have heard of people saying, my computer needs a memory upgrade. I need to upgrade my memory. Why do they upgrade the memory? Why do we need bigger memory? It's like this. Let's say you have some work to do and you need some workspace. You know, your desk is very small. You have a pile of papers to process. And if your desk is too small, it's going to be harder for you and you're going to be slower with your process, with your task. But if you have plenty of space, you'll be working faster. You can sort them out a little bit faster. So it's the same thing with the computer. The memory is the workspace for the computer. So if the workspace is plenty, then it doesn't have to manage the memory carefully. It has plenty of area, so it can carelessly work things out, so it'll work faster. It'll have to, if it has to look for available memory area to do the work, then it'll be spending time looking for available areas. If the memory is plenty, then it doesn't have to look for. It's all already there, right in front of it. So that's why when the memory is larger, the computer works faster. The workspace is plenty. And that's why people upgrade their memory. You know, you will see if the computer is slowing down, sometimes it's due to the memory. Well, not always. Sometimes the processor itself slows down over time. Anyway, memory is a part of the computer. It needs memory to work. And so you need to offer plenty of memory for the system to work. Let's think about the data processing. Data processing refers to providing data and program to the computer so that it can process and provide output. So what you provide to the computer are data and program. What you get out would be the output, the results of the processing. Now let's understand operating system. Now I said earlier, the computer cannot do anything by itself. It has to have the instructions to carry out anything. Computer doesn't know anything by itself. It doesn't have any brain, no thinking, no figuring out. So if you turn a computer on, if there is no program of any kind inside the computer, then what do you expect? You expect nothing. You turn the computer on, you only see black screen doing nothing. That's all you're going to see if there is no program in it. So, so if there is no program, you turn the computer on, you'll only see a black screen. You can punch your keys on the keyboard, you can move your mouse, nothing will happen because it doesn't know what they are. It doesn't know what to do when you move the mouse. It doesn't know what to do when you press the key. So that's why you need a program telling the computer what these things mean, what the keyboard click, what key means in the keyboard. When you press a key, what is it supposed to do? When you move the mouse, what is it supposed to do? All these things have to be given to the computer. So that's what the operating system is. It's a program. Operating system is a program that basically guides the computer through the process of being a computer or working like a computer, acting like a computer, and understand user interactions and all those. So without this operating system, the computer cannot function. It needs this operating system program in its memory. Remember, all its instructions have to be in the memory before it can function. It's like, imagine you having nothing in your brain, then you won't even walk. You, over time, you learn to walk and learn to do things, learn to behave like a human. All those are instructions in your head and you're functioning according to that. And so the computer needs instructions to function like a computer. And those instructions are the operating system and they have to be in the memory. When the computer is purchased, when you purchase a computer, they don't sell you just a computer because just a computer is of no use. It's a, computer without its operating system is just a machine that has no use. So therefore, they sell you the operating system with it, and the operating system comes on the hard disk. Hard disk is basically an external storage that is built into the box where the components of computer are. They put it inside the box, but it is an external storage. So that is where the operating system will be, because you cannot put it in the memory permanently. The memory is active and it holds information only as long as there is power. Only as long as there is electricity, the memory will be holding anything. And that's why when the computer is turned off, the memory is turned off. Memory is cleaned. Nothing will be in the memory. So that's why they put this operating system on the hard disk. And the computer is already instructed to find the operating system every time you turn it on. Every time you turn the computer on, there are a few seconds or sometimes minutes it takes to show things on the screen. And what is happening during that time? It is looking for the operating system on the hard disk. When it finds it, it copies it into the memory. Only after it copies the entire operating system into the memory, it's ready to interact with you. And that process of copying the operating system is what we call the booting process. So when the computer is booting up, it's actually copying operating system into the memory. And only after that is done, it'll be ready to interact with you and carry out everything you do, like moving mouse or typing on the keyboard or running a program. All those are understood because of the operating system. So let's understand the definition of operating system. Operating system is a program that controls the overall operation of the computer and human interaction with it. I should have added that the human interaction is also handled by the operating system. This program must be in the memory. So in the modern computers, they are in the hard disk, so you don't normally bother with it. You turn the computer on, the computer automatically finds the operating system and copies it into the memory. In the older times, when we, going back to the past, the computers didn't have hard disk. The idea of hard disk was not there at that time. At the time, I started using computers. So the operating system will come on a disk. That disk will be called system disk. So when you buy the computer, they have to give you system disk with it. And when you turn the computer on, you had to provide this disk. You had to put the disk inside the opening, and then it'll copy the operating system from the disk to the main memory, and then it'll function like a computer. You can take the disk out after that, because once it copies into the memory, then it's in the memory, and now it can function according to the instructions in the operating system. So the disk can come out after that, and then you can put other disks in and work with the computer. So that process was called booting process. And the booting process is now automatic. You don't have to put any disk in. It will find it from the hard disk and copy it. The different computers look and feel differently because of the operating system. What are the two main operating systems out there? The Macintosh uses what is called Mac OS. And what is the other one?
Windows.
Windows. These
Windows.
are the two popular operating systems, Windows and Mac OS. There are other things, Linux and everything, they're not very common, but there are one or two maybe other operating systems that there are not many, because writing an operating system it's a huge work. It's a huge task, and so not too many people want to do it. And especially when there are two operating systems already in the market, the Windows and the Mac OS, there is no way another one can compete and win, so nobody is making any attempt to write another operating system. So these are the most the common ones, Mac, Mac and the Windows. So these two computers are working differently because of the two different operating systems. The computer itself is not different. The machine itself is the same, essentially. Only the operating system makes them work differently. So between Windows and Mac, people have preference. I work with both, but I prefer the Mac. I personally like the Mac better than the Windows. In fact, the computer I'm using right now is a Mac, the iMac. I work with Windows too, but I prefer to work with the Mac. Anyway, that finishes section 1.1. You need to, so if you open up the section 1.1 in the book, at the end, you see these questions. For those questions, you just write the answers. Remember, when you're writing definitions, the keywords must be there to get the credit. I have seen wrong answers like these. When the question says, what is a computer? A student says a computer is a machine. That's not complete answer. You have to be more specific than that, right? So the key words are, it's a machine that can accept and act on data and instructions very accurately and at a high speed. Those features have to be there in the definition. So write up your answers, even though most of the answers are there in your chapter, section 1.1. You can copy them if you like, but there's a reason for that, for the questions. By answering them, you're learning. You're learning better by answering those questions. That's the idea. All right. Even though the section 1.1 is what your homework is on, we are going to do part of 1.2. So any question on this so far? Feel free to ask your question at any time.
Professor, I have a quick question. Where are we finding the assignments again? I'm sorry.
Where do you find what?
The assignments again? Like when I know you said turn it in, that's where you get submitted, but like where do you like actually find like the questions and everything?
Okay.
It's in the PDF where he had the first chapter. It's on the course supplements.
Yeah, it's in the first chapter in your book, section 1.1 in your book, if you have the book.
Okay, all right, thank you.
All right, if you don't have the book, I still have it posted here in the supplements. So if you're waiting for the book to come in, you can go to this chapter 1. It'll download. You can see at the bottom. Click that. There is chapter 1, and go to the end of 1.1.
It's the 12 questions, right?
Yeah, there are 12 questions here. See that?
Gotcha.
Okay, all right, thank you.
You need to write just the answers. Do not copy the questions. Just answers.
Got it, thank you.
You're welcome. Okay. Any other question? Okay. Then I'm moving on to 1.2. Okay. Oh, I already have it open. I forgot about that. Sorry. Okay, so 1.2, let's go to the beginning of it. Okay, lecture. I'm beginning this topic, but I won't be able to finish it, but we will finish it in the next class. Machine language, that's what we're going to learn here. I'm displaying this presentation on the left side of the screen because the right side is for my writing. What you see on the right side is my whiteboard for writing. Now, if this is, if you need to see it on the full board, full screen, I can do that, but then the whiteboard will be vanishing. Is this okay? Everybody can view it properly? Otherwise, let me know. Okay, so machine language we're going to understand. The machine language is the language of the computer, and to become programmer, we need to have a reasonable understanding of this language, and therefore that's our section 1.2, understanding the machine language. The only language the computer can understand is called machine language or ASCII code. ASCII code is another name for the machine language. But if I ask you a question in the homework or test that says, what is the language of the computer? Your answer should be machine language. Common wrong answer is computer language. There is no language called computer language, okay? Machine language is the name of it, and you have to use that name correctly. In this language, all the characters and numbers are going to be represented by a set of ones and zeros. Ones and zeros. These ones and zeros are called bits. There will be exactly 8 bits in the code of each character. Every character has 8-bit long code to represent it. These 8 bits are zeros and 1, 8 zeros and 1s. Why 0 and 1? Only 0 and 1 can be represented in the computer. And we will be learning the details of that later. So, for example, the character A, the letter uppercase A, has this code in the machine language. Similarly, character B, character C, they all have different codes. We don't have to memorize them, but you need to understand that they are there. So whenever you want to store the character A in the computer memory, this is what you're storing. But you won't be actually working with this machine code. You know, there are ways in which things you write in English will be translated by the system to the machine language. So you don't really have to learn to translate to this language. That'll be done for you. So, but we still have to have an understanding of this language to be able to program the computer. That's why we are learning this. So the reason why the characters and numbers have to be coded in this system using this zeros and ones is because only zeros and ones can be represented inside the computer memory. That's the reason. And we will understand that later. Now let's understand binary coding. To be able to understand the binary, to understand binary coding, let's think about our decimal coding system, the code that we are familiar with. The numbers that we write are written this way, like 52. You read this as 52. You don't read that as 52. Why 52? Because you were told that the 5 here represents 50. 2 represents 2. So this number, actual value of this coded number is 52. Writing 5 and 2 next to each other to code 52 is our coding system, which is called decimal coding system. And you didn't think in terms of that, but that's what it is. The 2 represents the number of ones. There are 2 ones, and there are 5 tens. 5 represents number of tens. So 5 tens and 2 ones are there. So the actual value of this number would be this. I'm writing on the board. The actual value of this number is 5 times 10, 50, plus 2 times 1. That's the actual value. This expression represents the actual value of the number we code by writing 5 and 2 next to each other. This is a code for this value. So when we write this number, 2,354, the 4 represents number of ones. The 5 represents number of tens. 3 represents number of hundreds. 2 represents number of thousands. We don't think that far. We just learn to read this number as 2,354. So to be exact, the 4 represents 4 10 to the zeros are there. That's what it means. 10 to the 0 equal to 1. So 4 ones are there. The 5 means 5 tens are there, or 10 to the 1. 5 10 to the power 1s are there. 3 means 3 10 to the power 2s, hundreds are there. 2 means 2 10 to the 3s are there. These are all powers of tens. So each digit here represents number of powers of tens in the actual value of the number. So the 10 is called the base of this system because it's all powers of 10 we are dealing with. And this system is called decimal system. Deci, the word deci stands for 10. So the decimal coding system uses power of 10. Why power of 10? Why 10? Because 10 is the easiest for us. 10 to the 3 will have 3 zeros next to 1. 10 to the 15 will have 15 zeros after 1. We can easily compute any power of 10. So therefore, we find it convenient. So we use 10 as a base. And so we are so used to it that we don't even think about the details. One other thing to notice is that the value of the numbers that go in front of these powers of 10s will be less than 10. There is no reason to write a 10 here instead of 5. If you write a 10 here instead of 5, that 10 times 10 to the 1 will become 10 to the 2, and 10 to the 2s are counted here. So that's why there will be never a 10 coming in here. So all the digits are less than 10, 0 through 9. Those are the digits, right? 0 through 9 are the digits that will go in front of these powers of 10 in this system. So we have these symbols to represent those numbers less than 10. 2 for the count of 2, 3 for the count 3. All these symbols 0 through 9 can go in front of these powers of 10. That's how this number system works. Now the question is, do we have to use 10? We don't. How about 5? Can we use 5 as a base and write all the numbers as sum of powers of 5s? Yes, we can. There's no reason to choose that. 10 is so easy for us, so we have been sticking with that. There's no reason to change that 10 base. Now, after the computers were invented, there is a reason now to change the number system because computer memory can only handle 0 and 1, 2 things, no more than that. So therefore, they came up with the numbering system with the 2 as the base. If I use, instead of 10s, if I use 2 here, then, and write the number as a sum of powers of 2, then all the digits in front of these powers will be less than 2. Less than 2 means what? 0 and 1. And that's beautiful. 0 and 1 are the ones the computer can handle. So that's why the number system was changed to base 2 for the computer. For the computer, the number system is going to use base 2. And that's the system we call binary coding system. Binary coding system is the number system with a base 2, which means all the numbers are going to be calculated, all the codes are going to be calculated by expressing the number as sum of power of 2, sum of powers of 2. So instead of 10, you had to use 2 as the base, and that means express the number as sum of powers of 2. So your value of the number should be now expressed as sum of powers of 2, which means 2 to the 0, 2 to the 1, 2 to the 2, and so on. Then if you write it that way, then the digits that appear in front of those powers will make up the code. Just like this, go back to this coding. This is the actual value of the number that we are dealing with. And when you express it as sum of powers of 10, the digits that are in front of these powers, this 2, 3, 5, and 4, written next to each other, is the code. In the same way, if you express the number as sum of powers of 2, then the digits that are in front of the powers of 2 which are going to be 0 and 1, will make up the binary code of the number. So let's see an example. 13. To find the binary code of 13, I'm going to write on the board now. Here's how it works. 13 is your number. You have to express that as sum of powers of 2. So you start with the 2 to the 0 and keep working up. 2 to the 1, 2 to the 2. 2 to the 2 is 4. 2 to the 3 is 8. 2 to the 4 is 16. Now 16 is too much. All these, what I write on the right side should add up to 13. So I cannot have 16, obviously. So that's why 2 to the 4 cannot be there. 2 to the 3 is the highest power. You always put a 1 in front of that. The highest power is going to be always included. So 2 to the 3 is included, and it's equal to 8. Plus, what number should I write in front of 2 to the 2? I have to figure that out. It can only be 1 or 0. It has to be less than 2. So should it be 1 or 0? I decide that it should be 1 because 1 times 2 to the 2 will be 4, and 8 plus 4 is within the 13. So therefore, I can include the 2 to the 2. Now, should I include 2 to the 1? I only have 12. If I include 2 to the 1, 12 plus 2 will be 14. That's too much. So therefore, put a 0 in front of that. Okay, finally, should I include 2 to the 0? Yes. How many 2 to the 0s? 8 plus 4. 8 plus 4 is a 12. I only need 1 2 to the 0. So 1 in front of that. So now the digits in front of these powers will make up the code. So this 1, 0, and 1. 1, 1, 0, 1 is the binary code of 13. So that's how you find the binary code. Express the number as sum of powers of 13. That will give you, then you find the powers, the number, the coefficients or the digits in front of the powers will make up the code. Okay, let me do the 37. And after that, you're supposed to do the 78 and 65 yourself. And I advise you to practice that at home before next class, then you'll be doing better. A good student would always prepare better for the class. And you will prepare better for the next class if you do these problems on your own, at your own time, before the beginning of next class. I'm going to show you 37. 37 is equal to 2 to the 0, 2 to the 1, 2 to the 2. You can include these, 2 to the 3, 2 to the 4. 2 to the 3 is 8, 2 to the 4 is 16. 2 to the 5 will be 32. And any more than that is too much, right? So I stop at 2 to the 5. And I put 1 in front of it. Largest power is always included. And 2 to the power 5, 32. Write that down. Plus, if I include 2 to the 4, that's 16. 32 plus 16 is too much. So therefore, that'll be a 0. Let me get the color. Okay, so 0 times 2 to the 4. And 2 to the 3 is 8. 32 plus 8 will be 40. That's too much. So therefore, that should be 0. And 2 to the 2 is 4. And 32 plus 4 is 36. So that is within 37. So therefore, I can include that by putting a 1. So that's a 4. So now I have 32 plus 4, 36. And now if I include 2 to the 1, then that'll be 38. They add up to 38. That's too much. So therefore, 0. And if I include this, that'll be a 1. That's exactly what I need. 1. So 32 plus 4, 36 plus 1, 37. So now I have the expression. That adds up to 37. So my binary code is 1, 0, 0, 1, 0, 1. Binary code of a number is not limited to 8 bits. It can be any number of bits. So this is the binary code, the answer to the question.
I have a question.
Yeah.
So basically, like with the exponents, you basically so like 2 to the 5th power is 32. So you basically want to get right before 37, like with the exponents. So like 0, 1, 2, 3, 4, 5. So you basically want end at 5, right?
Right. I end at
Okay.
5 because 2 to the 5, 32 is within the 37.
Okay.
2 to the 6 is too much.
Yeah. Okay. I just wanted to make sure. All right. Thank you.
Mhm. Any other question? Feel free to ask your question.
I still don't understand the part in the red where it's like 0x or it's like 0 times 2. Can you explain that again?
Okay. Let me erase that part, and I'm going to start over with that. So we are doing 37. So 37, I write the 37 on the left, and I need to have my 30. Let me change the color back. So I need to have my 37 should be now written as an expression, sum of powers of 2. That's what I need. So I write the 37 on the left and equal to, and then start writing 2 to the powers, 2 to the 0, start at 2 to the 0, work your way up, 2 to the 1, 2 to the 2. I'm including all these are all smaller than 37. So obviously they're going to come into the expression, 2 to the 3, 2 to the 4. These are all going to be included. 2 to the 5. 2 to the 2 is 4, right? I don't want to write that. 4. 2 to the 3 is 8. 2 to the 4 is 16. 2 to the 5 is 32. 2 to the 6 is 64. So since all these have to add up to 37, we don't want to include 64, right? So that's why I stopped at 2 to the 5. So always put 1 in front of the 2 to the 5 because the highest power is going to be always included. So this is equal to 32, right? The remaining things I write should be adding up with the 32 to make it 37. So next question is, can I include 2 to the 4 or not? 2 to the 4 is equal to 8. 16. So 16 will be 32 plus 16 will be too much, right? So therefore, I put 0. When you put 0 in front of it, the whole thing is becoming 0. So that's not included. Now, 2 to the 3 equal to 8. Can I include 2 to the 3? No, 32 plus 8 will be 40, which is over the 37. Are you following me?
Yes.
Yes. So that's why I'm going to put 0 in front of it. And next question is, should I put 1 or 0 in front of 2 to the 2? 2 to the 2 is equal to 4. And if I put a 1 in front of it, I'm including it. If I put 0, then I'm not including it. Can I include 4?
Yes.
Yes. So therefore, I put a 1 there. 1 times 2 to the 2. And so now I have 4, and 32 plus 4 is 36. And therefore, 2 to the 1 cannot be included, because that will make it 36 plus 2 will be 38, too much. So therefore that'll be 0. And 32 plus 4 is 36. I need a 1. So put a 1 in front of 2 to the 0, that'll give you a 1. So now it's adding up to 37. Did you get that?
Yes, thank you.
All right. So these digits now will be the code 1, 0, 0, 1, 0, 1.
Professor, did you call my name, Rahman?
Yes, I got your name.
All right.
So that's this is your code 100 101. That's how you find the code. And so I want you to do this 78 and 65 at home and bring it to next class so that we'll have a good head start. Okay. So we close here, and remember, your latenesses and absences will affect your grade indirectly. Okay, you will not get the rewards, and if you have too many absences and latenesses. So therefore, you want to maintain a perfect attendance and get your rewards. It'll always help you with the grade and also help you learn better.